Okay, previously we looked at this identity, sine 2 theta equals 2 sine theta cosine theta. However, this identity actually also works for other things inside. So if I have a 4 theta, then I would have a 2 theta and 2 theta here. If I have a 6 theta, 3 theta and 3 theta. So basically this allows other numbers to be put in here besides just 2 theta. Basically the way it works is whatever I have here, then exactly half of it is going to go inside there. Because remember, this is a double angle. It's double whatever you have inside here. This is 2 theta, so then that would be a 4 theta, 3 theta and 6 theta. Those are doubles of each other as well. So therefore I can really write anything in here that I want. So I'm going to have to use this idea on this problem when I want to establish the identity. So this problem is going to be a little bit unlike the ones we've done in the past. The ones in the past we've done before are ones where we can follow those techniques and strategies for going through. This one, we can't really apply any of those techniques here, so this problem is going to be done by just putting in repeated identities until we get both sides equal. So I looked at this and I would see one identity right here, 1 minus 2 sine squared. I should recognize that that's one of my double angle formulas for cosine. So I'm going to put that identity in there. That's going to be cosine of 2 theta. Now the rest of it, I'm just going to go ahead and bring that down as is. So right now the problem turns into this. I have 4 sine theta cosine theta times cosine 2 theta. And again, the idea is I want to try and get both sides equal. Well, I want to take a look at this and see if it resembles anything up here that I've already written down. Now it kind of resembles the first one because I have a sine theta and a cosine theta, and I notice I have sine theta cosine theta here, but I have a 4 there instead of a 2. Well, what I can do is I can rewrite the 4 as 2 times 2. So I can actually do this. I'm going to change it into 2 times 2 sine theta cosine theta. That's still going to equal 4 sine theta cosine theta when I multiply it out. I'm just rewriting the 4 into 2 times 2. And then I still have cosine 2 theta over here, and then that's equal to sine 4 theta. Now this part, because I've separated it, this whole thing now turns into sine 2 theta. So the 2, I'm just going to bring that 2 straight down there. This whole thing here, 2 sine theta, all of that actually, this whole thing, that gets written as sine of 2 theta. And then this is going to be cosine 2 theta here. And then the right hand side I haven't done anything with. Now this whole thing, 2 sine 2 theta, cosine 2 theta, all of that can be written down, be changed into sine of 4 theta, because that's the identity I have on the board right here. So I'm going to put sine of 4 theta in here, and so now I get both sides equal. Sine of 4 theta equals sine of 4 theta. I've shown that both sides are equal. So again, this right here, I used really 3 different identities. Here's the first one. I did 1 minus 2 sine squared turned into cosine 2 theta. And then I brought that down, changed the 4 into 2 times 2, and then this whole thing was another identity. And then now the whole thing becomes another identity again. So I actually used 3 different identities in order to get that. So again, the idea is still the same. You're trying to work out one side all the way down until you have one side equal to the other side.